As we know that in today's world, we use various electronic devices or equipments such as security systems, washing machine, fridge, refrigerator, mobile phones, computers, and all these devices uses digital ICs, and logic gates are basic building block of digital ICs. So we will discuss what is logic gate, types of logic gates, and symbol of each logic gate, and the mathematical relation between input and output expressed in the form of boolean expressions will also be discussed. And finally, we will discuss the truth table. What is logic gates? Logic gates are basic building blocks of all the digital circuits because each and every digital circuit uses logic gates. A logic gate is electronic circuit that performs a logical operation on one or more binary inputs that produces single binary output. So we can say logic gate has one or more binary inputs, but it has only one binary output. Binary means the signal which can have only two values, either 0 or 1. Logic gates are the electronic circuits in digital system. Logic gate consists of resistors, transistors, or diodes. So logic gates are basically formed with the help of resistor, transistor, or we can say diode. The relation between inputs and output of logic gate is expressed mathematically as a boolean expression. So with the help of boolean expression, we can show the relation between input and output of logic gate. Types of logic gates. There are several types of logic gate which are used in performing operations in digital systems as given below. NOT gate, OR gate, AND gate, XOR gate, XNOR gate, NAND gate, and NOR gate. NOT, OR, and these three are the basic logic gates. XOR and XNOR are the derived gates. NAND gate and NOR gate are called as universal gates. So we can say logic gates are divided into three categories: basic gates, derived gates, and universal gates. What are the universal gates? A universal gate is a logic gate that can implement any boolean expression or function without using other logic gate. So we can say we can build or develop any boolean function with the help of single gate. The universal gates are NOR and NAND. So we can say we can develop any boolean expression with the help of either NAND or only with NOR. It doesn't require any other additional logic gate. NOT gate. When you say NOT gate is an inverter. When you say inverter, means it will invert the input. If input is 0, it will make it 1. If input is 1, it will make it 0. Hence, if 0 is applied as an input, the output will be 1, and vice versa. Symbol. This is symbol of NOT gate. Triangle, and in front of triangle there is a hollow bubble, and this form a symbol of NOT gate. Boolean expression of NOT gate is shown here. Y is equal to A complement. Truth table. Input. NOT gate has only one input, input A, one output, output Y. Y is equal to not A. If input is 0, then output will be 1. If input is 1, then output will be 0. So what it is doing? It is just inverting the input. It will converting 0 into 1 or 1 into 0. Now we will see the NOT gate IC. IC 7404 is NOT gate IC. Here we have shown the IC. This is 14 pin IC. This is a notch of IC, and we count the pin number from when we keep notch on left side. So from bottom left pin, pin number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is the 14 pin IC. Here pin number 7 is ground and pin number 14 is VCC. So pin number 7 is always connected to ground and pin number 14 is always connected to plus 5 volt. And this is the internal diagram of IC 7404. Here, as we can see, NOT gate has 6 NOT gates inside single IC. 1, 2, 3, 4, 5, 6. Here pin number 1 is input pin and pin number 2 is output pin. If here we apply logic 0, then here we will get logic 1. If we apply logic 1, here we will get logic 0. In the same way, we can have a 6 NOT gate in a single IC. IC number is 7404. AND gate. In this slide, we will discuss what is AND gate. In AND gate, output of AND gate is 1 if and only if all the inputs are in state 1. So your output of AND gate will be 1 if all inputs are 1. See, AND gate has 2 input, input A and input B, and 1 output Y. And this is a symbol of AND gate. Boolean expression. Y is equal to A dot B. So we can say this is Boolean or mathematical expression of AND gate. Basically, AND gate is does the product of 2 inputs, A dot B. Truth table. Input. AND gate 2 input, input A and input B, and 1 output Y. Y is equal to A and B. 0 into 0, because mathematical expression is A dot B. So 0 into 0, it will be 0. 0 into 1, it will be 0. 1 into 0, it will be 0. 1 into 1, it will be 1. So if all inputs are 1, then and there output of NAND gate will be, output of AND gate will be 1. AND gate. IC 7408 is AND gate IC. This is 14 pin IC. It has 14 pins and we count the pin number. Suppose this is a notch, then this will be pin number 1, 2, 3, 4, 5, 6, 7. Pin number 7 is ground pin. 8, 9, 10 up to 14, and 14 will be VCC. Here we have shown the internal diagram of AND gate. Suppose this is a notch and this is pin number 1. Pin number 1 and 2 are inputs and pin number 3 is output. So we can say this is A input, this is B input, and this is Y output. In the same way, in a single AND gate IC, we have 4 AND gate. So we can perform 4 AND operation with the help of single IC. IC number of AND gate is 7408. OR gate. In an OR gate, output of OR gate reaches to 1 if 1 or more inputs are set to 1. Means if we have OR gate and it has 2 inputs, if any one input is 1, then your output will be 1. Symbol of OR gate. Here it has 2 inputs, input A, input B, and 1 output, output Y. Boolean expression. Y is equal to A plus B. This is Boolean expression of OR gate. So OR gate do the addition of 2 inputs, A plus B. Truth table. Input, output. OR gate has 2 inputs, input A, input B, and 1 output. Y is equal to A or B, or we can say Y is equal to A plus B. 0 plus 0, output will be 0. 0 plus 1, output will be 1. See, in this case, B is 1, so output 1. The condition is that any one input should be 1 to get the output 1. In this case, A is 1 and B is 0, so output will be 1. In this case, A is 1, B is 1, then also output will be 1. So we can say if more than one input is 1, then your output will be 1 in the case of OR gate. OR gate IC 7432. This is IC 7432 which has 14 pins. This is pin number 1 to pin number 7, 8 to 14. Pin number 7 is ground and pin number 14 is VCC. Here we have shown the internal diagram of OR gate. In single IC we have 4 OR gate and pin number 7 is ground and pin number 14 is VCC. In this case, pin number 1, 2 are inputs and 3 is output. Pin number 4 and 5 are inputs and 6 is output. For this, pin number 10 and 9 are inputs and 8 is output. In such a way, we can be able to know which are the inputs and which are the outputs of IC 7432. Now we will see NAND gate. NAND gate is basically logic gate, and this is a combination of and NOT gates. So this is symbol of NAND gate. So here bubble is shown. Bubble indicates NOT gate or inversion. So AND plus NOT. This is a, we can say, inverse of the AND gate. Boolean expression y is equal to a dot b and its whole complement. So it will be opposite to the output of AND gate. This is truth table. NAND gate has two inputs A, B and one output Y. Y is equal to A NAND B. If A is 0, B is 0, then your output will be 1 because it will A into B, 0 into 0, 0 and its complement it will be 1. Next, 0 into 1 it will be 0 and its complement 0 and it will be 1. 1 into 0 it will be 0 and its complement will be 1. For last case, 1 into 1, its product will be 1 and its complement will be 0. So in the case of NAND gate, if all inputs are 1, then your output will be 0. If otherwise, it will be 1. Now we will see NAND gate IC. IC number of NAND gate is 7400. NAND gate IC is again a 14 pin IC. It has 7 pin on one side and 7 pin on other sides. Pin number 1 to 7 and 8 to 14. Pin number 7 is ground and pin number 14 is VCC. Here we can see single NAND gate IC has 4 NAND gates. So we can do the 4 NAND operations with a single IC. Pin number 7 is ground, pin number 14 is VCC. Here 1, 2 are input and 3 is output. 4, 5 are inputs and 6 is output. 13, 12 are input and 11 is output. NOR gate. This gate is a combination of OR and NOT gate. Symbol. This is symbol of NOR gate. This is symbol of OR, and when we add a bubble in front of OR, it becomes NOR. So we can say it is a OR plus NOT. Boolean expression. Y is equal to A plus B. As we know, the logic expression for OR gate is A plus B. And for NOR, take its complement. So it will become the logic expression for NOR gate. Truth table. NOR gate has two inputs A, B and one output. Y is equal to A NOR B. So in this case, it is a combination of OR plus NOT. So 0 plus 0 is 0 here. 0 plus 0 is 0 and its complement. It will be 1. Here A is 0, B is 1. 0 plus 1, it will be 1 and its complement will be 0. So in the case of NOR gate, when both inputs are 0, then your output is 1, otherwise 0. So just keep this equation in mind. Y is equal to A plus B, its complement. So if both inputs are 1 1, 1 plus 1, it is 1 and its complement is 0. So 1 plus 1, its output will be 0. NOR gate. IC number of NOR gate is 7402. IC number here 7402. Again, it is a 14 pin IC. It has 14 pin. Pin number 1 to 7. 7 is ground and 14 is VCC. This IC has again 4 logic gates. We can say 4 NOR gate in a single IC. Here, just see in this IC, there are pin numbers are changed of input and output. Here, pin number 1 is output and 2 and 3 are input. Here, pin number 4 is output, 5 and 6 are input. In previous ICs, there were 1 and 2 were inputs and 3 was the output. So keep in mind, this was the change compared to the other ICs. IC number of NOR gate is IC 7402. Exclusive OR gate, XOR gate. In an XOR gate, output of 2 input XOR gate attains 1 if 2 inputs are dissimilar. So in the case of XOR gate, its output will be 1 if input A and B are different. Symbol. This is symbol of XOR gate. We also call it as exclusive OR gate. Mathematical expression: Y is equal to A XOR B. We can also write it in different form. Y is equal to A bar dot B plus A dot B bar. Truth table. XOR gate has 2 input A and B. Output Y, which is equal to A XOR B. As we discussed, definition of XOR gate, its output will be 1 if 2 inputs are dissimilar. See, in this case, A is 0, B is 0. So both are same, so output will be 0. In this case, A is 0 and B is 1. So see, these 2 inputs are different, hence output is 1. Here A is 1, B is 0. Again, these 2 inputs are different, so output is 1. Last case, A is 1, B is 1. Now these 2 inputs are same, so output will be 0. So only keep this sentence in mind. If 2 inputs are different, then and then your output will be 1 in a case of XOR. Exclusive OR gate, or we can say XOR gate IC. IC number is IC 7486. Again, this is a 14 pin IC. Pin number 7 is ground and 14 is VCC. Again, single IC has 4 XOR gates. Here pin number 1 and 2 are inputs and 3 is output. 4, 5 are inputs and 6 is output. Here 13 and 12 are input pins of XOR and 11 is output. Here 10 and 9 are inputs and 8, 1 is output. Only in all these ICs, only change is with XNOR gate IC. IC number is IC 7486. Exclusive NOR gate. In XNOR gate, output is in state 1 when both the inputs are same. That is both 0 or 1. So in the case of exclusive NOR gate, your output will be 1 if both the inputs are same. See, this is symbol of XNOR gate. Here we have just added bubble in front of XOR gate, so it becomes a XNOR. Again, this is a XOR plus NOT. Here boolean expression: Y is equal to A XOR B and its complement. We can also write this expression in other form: Y is equal to A dot B plus A bar dot B bar. This is boolean expression. Truth table. Input, it has 2 input, input A, input B, and output, it has 1 output, Y. If 2 inputs are 0, 0, A is 0, B is 0, then output is 1. As a statement says, if both inputs are same, then your output will be 1. If both inputs are different, then output will be 0. Here A is 1, B is 0, so output is 0. In last case, A is 1, B is 1, both inputs are same, hence your output is 1. Just keep in mind, both inputs are same, then your output will be 1. Now we will discuss exclusive NOR gate IC 74266. IC 74266 is exclusive NOR gate IC. Again, this is a 14 pin IC, same. Pin number 7 is ground and 14 is VCC. See, in this case also we can say NOR gate IC. Here pin number 1 is input, 2 is input and 3 is output. Here pin number 4 is output, 5 is input and 6 is input. Again here pin number 8 and 9 are input and 10 is output. 13 and 12 are input and 11 is output. This IC number is 74266. This is exclusive NOR gate IC. Now this is last topic of our session, uses of logic gates. IC foundation. Logic gates are the foundation of integrated circuits in computers, phones and electronic devices. So we can say logic gates are basic building blocks of integrated circuits, and these integrated circuits or ICs are basically used in computers, phones and electronic devices. This is one of the use. Versatile combinations. They enable diverse combinations crucial for modern technologies like gadgets, satellites and robots. So we can say logic gates are also used in gadgets, satellites and robots. Home automation. Logic gates are also used in smart switches, devices to make decisions on turning lights, appliances or heating systems on or off. So we can say various smart switches uses logic gates. Traffic lights. Logic gates control the sequencing of traffic lights, ensuring smooth traffic flow through the logical signal changes. So we can say logic gates are also used in traffic lights. Industrial significance. Widely deployed in data transportation, calculations and processing. Logic gates are integral to the transistor logic and CMOS circuitry. So we can say logic gates are also used in TTL circuitry and CMOS circuitry. These are the some uses of logic gates.